Give me a second. All right, we're recording. All right, so for this question now, how do you plot two functions in the calculator so that we can find the intersection point, right? How? Simple. So in the calculator, you're gonna go here in this key where it says y equal. Where it says y equal, you're gonna write down the first and the second function. So in my case, we have x minus 1 as the first function. Make sure you write x using this key. This is the key for variables. Do not use, where is it? Do not use OPQ. Do not use this x, the one in green, right? Do not use this one. Use this one over here. Okay. Also, for minus, do not use this one. This is the negative. This is the minus. All right. So again, x minus 1 in the first one, and in the second one, 2x. Now, make sure your lines, your equal signs, are highlighted. Look, if I locate myself in the equal line and press enter, I am going to unhighlight the equal sign. What that does is that now if I graph, I am only going to graph the first function because it's the only one highlighted. I need to have both functions highlighted. All right, beautiful. Also, before we graph, maybe sometimes, since we are talking about statistics with the calculator, sometimes you have, let me just go back. Maybe you have statistics plots in the calculator. And the calculator uses the same screen for statistics plots and for functions. So we want to tell the calculators to don't plot statistics. How? Here, in statistics plot. So second y equal. That is the statistics plot, right? Just press the first one. And here, every statistics plot should be on off. Every single one should be on. In the second one, in the third one, every single one should be on off. Third one, off. Every single one of these should be on off. If you have one on, then you are plotting statistics points, statistics plots. And we don't want that in this exercise, right? So now that I have everything in off, I can go back and I can continue with the graphing. Again, we have our two functions in y equal. To graph those two functions, I simply press graph. And after a while, the calculator is going to begin graphing the two functions. That's it. Now, if you don't see this, it's maybe because your calculator have a different window. So you can change that using the window key here. Simply select a different value for minimum of x, a different value for a maximum of x, a different scale, all of that, right? Or a different option, which is to simply zoom out or zoom in. It depends on what you want. If you want to zoom out, you press the key zoom and then 3 for zoom out. If you want to zoom in, then the key zoom and then 2 for zoom in. That's it. In my case, I can clearly see what is the intersection point. If you cannot see where is the intersection point, you have to zoom in or zoom out or simply change the window until you find that intersection point. You need to be able to see the intersection so that you can tell the calculator to find it. Now that you can see the intersection, you can tell the calculator to find it, to calculate the intersection. To do that, we're going to use this key over here, the calculate, calc, right? So that is done with second and trace. Here, we can calculate a lot of values. We can calculate values, we can calculate zeros, minimums, and maximums, but we care about the intersect point, the intersection point, because that is what we are being asked in here. So enter here an intersection. Now, the calculator is going to ask you for things. In this context, curve is not a circulito. It's not a circle. A curve is a function. And in our example, we have two functions, the red one and the blue one. Two lines, two functions. So we want the first curve to be any of those. Maybe we want this one, the red or the blue. It doesn't really matter which one we want. Just select one and press enter. After a while, the calculator is going to ask you to select the second curve. So simply move to the other one and press enter. Now I have two curves selected and the calculator is expecting me to give it a guess. So I need to guess where I think is the intersection. How do I guess? Just move a little bit to where you see is the intersection. Now, I can see the intersection is right here in my mouse. So I'm gonna scroll down or to the left and around there. I feel like the intersection is around there. That's what I feel. That's what I guess. It doesn't really matter if you screw up and don't select the proper intersection. It doesn't matter. Just select one as close as you can. Press enter, and after a while, the calculator is going to give you the answer. Intersection is for x equals -1 and for y equals -2. This is how we write it as an answer. The answer A is parenthesis -1 comma -2. Why? Because this is a point, and we know all points in the plane are written as x comma y and inside parentheses. So this is how we write our answer. -1 comma -2 inside parentheses. All right, that's it. That is the first question. I am not gonna do the second one because it's the exactly same process. All right. Let's try to do question 2. The managers of a factory are trying to determine what to charge for an item they make. All right? Okay, so simple. So far, so simple. The demand of the item. So what is demand? The demand is a measure of how many are likely to sell. So maybe they are likely to sell a lot of items, meaning the demand is high. In this exactly moment, so that you guys kind of understand the idea, the demand of facial masks is high because every single body, every single person on earth wants to have a facial mask. So the demand is high. That is the demand, a measure of how many are likely to sell. So the demand for the item can be modeled using this formula right there. That is the formula. D of P equals, that is how you read this, D of P. In here we read it as f of x, g of x, f of x, g of x. So here we have D of P is 800 minus 2P. Now what are P and what are D? Simple. P is the selling price in dollars. So according to the selling price, we have our demand. So you would assume if we have a lower price, so P is low, then the demand is pretty high. And it makes sense. It makes sense because if we don't have to pay a lot for the item, then everybody wants to have that item because it's really cheap, right? Okay. And the supply for the item. So what is a supply? The supply is the number that can be made, the amount that can be made. These are how many we can sell, and this is how many we can make. In this exactly moment of our time, talking about facial masks, I don't really know what would be the supply, right? I think that simply because we are in a pandemic, right? And a lot of people are trying to help each other, I feel like the supply is high as well. Every single company is trying to make masks, facial masks, right? Everybody that I know that likes to get into business to make some money is trying to sell masks, right? Because a lot of people need masks. So the supply is also high, right? Not only the demand, but the supply is also high. Okay, so the supply can be modeled using this other function. So we have two functions, D of P and S of P. In both cases, P, the independent variable, P, is the price. But D is the demand and S is the supply. So let's jump into the questions. Question A, sketch both functions on the same set of axes. That is absolutely easy if we have a calculator. If we don't, we're gonna have to do this by hand. I'm gonna show you how to do it with a calculator. So in here, I go back to the y equal, and I have to delete this, right? So clear, and then clear the second one, right? For the first one, I'm gonna write down the first function. Now, the variable here is P, and I don't have a variable P. The only variable that I have is X. It doesn't really matter. Just plot it with X. just plot it with x, and we know that at the end, the variable x is our variable p. All right, so 800 minus 2x. All right, that is the first question, the first function. And for the second one, it's 3p, so 3x. Enter. To graph it, simply press graph, and after a while, the calculator is going to begin plotting the functions. Now, if you cannot see it like me, if you cannot see the functions like me, that is simply, again, simply because we are not using a proper window. So I'm just going to zoom out all the way until I find a proper window. For a while, there I have one function, and I have the other one. Okay, so I can now kinda see the two functions. But if, let's say, I want to see the intersection point, well, I cannot see the intersection point right there. I cannot. So I'll simply zoom out a little bit more. Zoom out. Enter again. And after a while, the calculator should give me both lines there. And now I have the intersection point. Okay, now I have the intersection point. All right. So this is the sketch of both functions. Now let's go into B. Find the equilibrium point for this item. So what is equilibrium? What is that? All right, the equilibrium point is where supply and demand are equal. So I want supply, that is the second function, and demand, that is the first function, to be equal. In mathematics, two functions are equal right in the intersection point. So all we have to do is find the intersection point. So we're going to do the exact same that we did in the past question. Second and trace to calculate, and scroll down to intersect. Enter. And now first curve. Let's say the blue is the first curve. And now let's say that the red one is the second curve. Again, the calculator is going to ask me for a guess. So just move a little bit to where I feel is the intersection. I think like right there is the intersection. So I press enter. And after a while, the calculator is going to give me the answer. So in X, we have 160. And in Y, we have 480. Okay, there we go. We have the intersection. Beautiful. C, let's go for question C. Comment on the situation in which the selling price is 100. What? The selling price is 100? What do you mean? Okay, we're gonna comment on this in a while. First, I want us to do a little bit of an analysis of this intersection point. So we have a value of X of 160, right? But we knew, simply because of the way we wrote the functions here, we knew that X is our P, right? X is our P. So what does it mean that X is an intersection of 100? The intersection of the points have a value of X of 160. Well, it means that demand and supply will be equal when the price is $160. Right? Because again, our P is X. Our P is our value X. And P is the selling price in dollars. That's what it says here. Selling price is in dollars. So the equilibrium will be met when the price of the item is exactly $160. Okay? I lost the value of Y. All right, let me just calculate it again real quick. Intersect, right? First curve, second curve, guess. There. All right, the Y value is 480. So what does that mean? All right, that means that at exactly $160, if we put that as a price, $160, the demand will be 480 items. Remember, demand is how many we are likely to sell. So we are likely to sell 480 items. But also, in the supply is how many we can make, how many items we can make. And that is exactly this. We can make exactly 480 items. So the exactly amount that we make is the exactly amount that we sell. Okay, cool. That is the analysis of this, right? That is the analysis of this. Now let's jump into question C. Comment on the situation in which the selling price is $100. The selling price. So the selling price is the X value, right? So in our case, P. The selling price is 100, right? So what that means is that at 100, let me just calculate here. When X, we're going to calculate a value, right? So for X, we want to calculate 100, right? When X is 100, in the first curve, we have a value of 600. What does that mean? All right, that means that when the price is $100, we are expecting to have a demand, because we are on the first curve, this is the curve of the demand. We are expecting to have a demand of 600, right? We are expecting to have a demand of 600. But we are expecting to have a supply. Now, look, I am located on the second function, the second curve, the curve of the supply. We are expecting that we can only make 300 items. I'm sorry. No, yes. We can only make 300 items if we set the price at $100. This is the comment here. At $100, supply is lower. This is the supply. The red one is the supply, right? Supply is lower than the demand. Demand is lower than supply. What that means is that people want more and we cannot give them what they want. That is what's going on there. If we set the price to 100, people want more than when we can give them. All right, that is the comment there. Beautiful. Now, let's go with D. Contrast your answer in part C, so this one, to what happens when the price is 250. All right, so what happens if the price is 250? Let's do the same. Second and calculate. We're going to calculate a value of X for 250. So when X is 250, we have a demand. Look, I am located in the second line, this line with this function, which is the function for the demand. So when the price is 250, we have a demand of 300 items, meaning if each item is worth, or no, if each item costs $250, we only have a demand of 300 items. But the supply is a lot higher. The supply is a lot higher. Look, if we ask for $250 for each item, we can make 750 items. This is how many we can make. So we can make more than we can sell. Supply is higher than demand. We can make more than what we can sell. And it makes sense. When we were at $100 per item, so around here, supply was lower than demand. People wanted more because the price is low. The price is low, so people want more. But again, since the price is low, we don't have enough money to make as many items as we would like to make. Supply is low, but the demand is high. And when we increase the price, 250, if we increase the price, well, now people are not going to pay for that. So demand is now lower. Only 300 people, let's say this is people, so only 300 people want to buy the item. Why? Because we are asking for $250 per item. Now, with that same amount per item, we can make 750 items. That means the supply is higher than the demand. That is the idea behind supply and demand. Every time we have a supply and demand, we have a lower part and an upper part, and we have an equilibrium. All right, cool. That's question number 2. We're going to stop for these questions. These ones, you can do them yourselves. And we are going to jump right into 5G. The 5G are the ones that I feel like are a little bit more complicated. All right, a little bit more complicated. So I'm going to explain this one. I'm going to explain as much as this as I can, because I feel like these ones are going to be a little bit more complicated. All right, again, the easiest part for me to explain an exercise is to jump into one of the exercises. And if there's something new that we have to teach them, we will teach them from there. All right, so for functions B, C, and D, from investigation 6. All right, so let's go back to the investigation 6. Where is the investigation 6? Investigation 7. Investigation 6. All right, so we have 3 functions. We have B, C, and D. For these 3 functions, right? Here, if you have the book, you can just go up to page 226. There is the location of investigation 6, right? So for these 3 functions, we have to do things. All right, let's go down and see what are the questions. Here. For functions B, C, and D from the investigation 6, explain why each has an inverse function. Okay, an inverse function. What is that? An inverse function. All right. So let's explain first. Let's explain what is an inverse function. Okay. So right here is a good explanation for an inverse function. So let's say we have this equation. C equals 2 pi r. No, you know what? Let me use my board. I feel like it's a lot easier with my board. Board here. And then I want this. All right, guys. Can you see me? Hi. Can you guys see me?
Yes.
Anybody?
Yes.
Thank you, guys. All right, so maybe you guys saw inverse functions in the past, and I'm sure you did because some of you did it with me in 9th grade. Ooh. So maybe you guys don't remember what is an inverse function, but you guys saw it. You guys saw it. Here's a quick review. So let's say we have this little formula over here. This is the formula for our circumference of a circle. The circumference of a circle. The perimeter of a circle. The circumference. 2 pi r, right? R is the radius of the circumference So this will be the value of r, right? This will be the perimeter, right? Okay. So in this function, this is a function. If we wanted to change it for value of y and x, this is what we have, 2 pi x. We can plot this using any type of software, even in the calculator. You can write that down in the calculator, 2 pi x, and you're going to have a function. So some functions have inverses, some functions. And the inverse is go backwards in the function. So here's how you can see it a little bit better. Let's say that I want you to find y if x equals 3. So from here, I have a value of r, a value of x, of 3. So I have 2 pi times 3, right? Using the function means replacing the value of x, so the independent variable in the function. I just replace it. And this is going to give me a value for the dependent variable, the value of y, our perimeter. In this case, the perimeter will be 6 pi. This will be the perimeter, right? This is how we use a function. We replace for x, and we find the y. An inverse function is go backwards. Don't use the formula or the function as usually. An inverse function means in the exact same example, I am not going to give you the value of x, I am going to give you the value of y. So we know the perimeter, the y. Y is perimeter. So we know the perimeter of our circumference. Let's say I want to find X, so the radius, if the perimeter Y equals, let's say, 7 pi, right? We know that the perimeter Y, the dependent variable, again, we call it dependent because it depends on something. In this case, you know that Y depends on 2 pi and X. Y depends on these three. So Y is the dependent variable and X is the independent because this one doesn't depend on anything, right? In this case, I am giving you information for the dependent variable. How do you find X? All right, this is something really simple, right? We just replaced in the formula. This is 7 pi equals 2 pi times X, right? Let's just now write down the parentheses. And from here, you would have to isolate the variable X. This is not using the formula or the function properly. We are not replacing the value of X, the independent variable, to find the value of Y, the dependent. We are not. We are doing it backwards, right? You are familiar with this. You have done it 100 times, 100,000 times, right? To isolate X here, you just divide by 2 pi on both sizes, right? So 7 pi over 2 pi is the value of X. And now, look at this. Now, simply because I isolated one variable, simply because I isolated the independent variable, this one, the X, the independent, is now dependent on two things. 7 pi, a division, 2 pi. Three things. The independent variable became the dependent one. That is the idea behind an inverse function. To change the two values, change the dependent for the independent. All right. In this case, real quick, X will be 3.5, right? All right. This is pretty simple. Now, how do you find inverses? How do you find inverses? Sometimes some functions have inverses and some other functions don't. I'm going to show you the process, and I'm sure the moment I show you this, you guys are going to go like, ah, right, we saw that. Look, let's try to find the inverse function of this one. P equals 2 pi r. That is the function that we were talking about. R is the radius in our circumference, P is the perimeter. If this is the function, how do we find the inverse? Let me just change this real quick. I don't want to use that function. I want to use it like this. F of X equals 3x minus 1. Like that. I think that one is better. Maybe you guys are familiar with this. All right? This is the function. We know this is a function because this is f of X. This is the function. And we are being asked to find...
Juan Sebastián Patiño. Juan Sebastián Patiño.
Vale.
¿No está Juan Sebastián? Ok.
Vale.
Santiago Pérez.
Vale.
Santiago. Daniel Esteban Rivera.
You know what? In a minute, somebody naked is going to go by.
Daniel.
Lorena.
Juan David Rodríguez.
All right, sorry about that, guys. I just muted Vale. All right. Okay, so we have to find this. F to the negative 1 of X. This is how you write an inverse, right? The negative 1 on top of the function means, focus camera, please. Camera. The negative 1 on top of the function means the inverse, right? So we are finding the inverse of the function. Now, how did you find it? How did you find it? Pretty simple. There are a couple of steps you need to take, a couple of steps. The first one, recognize that instead of doing f of X, we're going to call it Y. So now we have the variable, the function Y equals 3x minus 1. Second step, we're going to interchange, switch the two variables. So we have the first one that was y, now it's going to be x. And the second one that was x is now going to be y. Minus 1. Do you guys remember this? The changing of the functions? From here, simply isolate the variable y. So we have, if we're going to isolate these, we're going to take a little by little. So x plus 1 is going to be 3y. The negative 1, I add it to the other side. From here, if I want to isolate, I want to take out that 3 by dividing, right? So x plus 1 over 3 is going to be y. And now I just found the inverse of my main function. Since this is the inverse, we call it 3. This is the f of f negative f to the negative 1 of x. This is the inverse function. Like this is how we find any inverse of any function. Now, there are cases when functions don't have an inverse, right? There are cases where functions don't have an inverse function. And the reason for that is because maybe once you have isolated the variables, maybe the function has some problems on the domain or on the range, making it so that the function is no longer a function. That is the case, for example, of a quadratic function. If we isolate it, the quadratic function doesn't really have an inverse. I'm not going to choose here. I'm going to leave it as a homework. If you want to, because it's not real work, right? If you want to check it, just do the exact same process with that quadratic function. And you're going to see that at the end, the result is going to give you difficulties, going to give you problems. The result is not a function, right? In some of the cases, the functions that we're talking about are not even algebraic like this. Are functions like, are functions that are being described like the ones we have in the book, right? So we have to analyze if the result is a function or not. To do that, we have to remember what is a function. Did you guys remember that? Did you guys remember what is a function and what is not a function? So if I do this, tell me that you guys remember. Please tell me that you guys remember. Please tell me that you guys remember. All right. 1, 2, 3, A, B, C. Please tell me that you guys remember this. If I do this, this is a set A. Oh no, let's say this is the set X and this is the set Y. To use the same formulas. And this is the function f of x. No, this is the function f. Did you feel like f is a function or is not a function? Okay, Majo Gutierrez remembers. Dani Perez cree que sí. Majo Cerón definitely remembers. Thank you, Majo. Again, guys, is this a function or is not a function? In the chat, please. Don't be scared of making mistakes. It's not a function. Thank you, Mafe. Are you asking or are you telling me?
Are you
telling me that you're telling me or are you asking me that you're telling me?
I'm telling you.
Okay, Mafe, thank you. Appreciate it. All right. And I appreciate your answers in the chat to the 4 people who answered. Yes, this is not a function, right? This is not a function. Why? Number 1, the main difficulty or the main rule that we have for a relation. This is a relation, a bunch of lines coming out from one set to the other set. That is a relation, right? So the main restriction that we have for a relation to become a function is that none of these items in the first set, in the input, none of those can have 2 lines coming out of it. So if we happen to have one element in the first set, so one element in the input, that is the name of the first set, the input, let me write it here, input. You guys saw this with me, right? Some of you, two of you, so this with me, right? If one of these elements in the input is related to two or more, then it is not a function. And that is exactly what is happening right here. This element is that is not a function right there. Simply because of that. With this element, that's a function. Even if I do this element, that makes it a function. You guys can see it, sorry. There. Right? The 2 and the 3 are not a problem because these 2 and 3 are related to one element. The problem is the 1. The 1 is related to 2 elements. 2 arrows are coming out of the 1. The 1 has 2 images. That is how we call the digits or the elements on the other set. The images of the first one. So what is the image of 2? C. What is the image of 3? B. In point 1 has 2 images, A and B. And that is a problem. No element from the input can have 2 images. And I'm teaching you or reminding you a lot of terms in here. Input, image, output, relation, function. We're talking a lot of, we're using a lot of terms that you guys knew from 9th grade that hopefully you guys are kind of remembering now, right? Now, what if I do this? What if I do that? What if I do that? Right there. What if I do that? Is that a function? Yes or no? In the chat, please.
It's not a function.
Mafe says that it's not a function. Paul says that it is a function. So now we have 2 people arguing, right? 2 people arguing, right? Sebas Moreno says that it is a function. Anita Herrera says that it is also a function. So Majo, why don't you tell us why you feel like it is not a function? Mafe.
Mr. You said Majo.
Sorry, Mafe. I meant Mafe. Sorry, Mafe.
No, Mister, it's a function.
It is a function. You sure?
I'm not sure.
Okay. Why are you not sure? What is going on? Why do you feel like maybe yes or maybe not? It's okay to have mistakes. All right. It's all right. Just speak your mind. Don't worry.
It's because 2 it's with C and so 1 is with B and 3 is with B. So both is with B.
Okay.
So a function can
have 2 lines, right? Cannot have 2 lines. Thank you, Mafi. I appreciate your input. Thank you. All right. So I decided to leave that drawing like that because I knew this could happen, right? This element has 2 lines. Didn't you say, teacher, that a set couldn't have 2 lines? Yes, I said so. But I said it for the input. No elements on the input can have 2 images. So no lines, no element on the input can have 2 lines. But on the output, that doesn't really matter. On the output, that doesn't matter. In this case, the B has 2 pre-images. I'm going to write those names in here. Image and pre-image. All right, so an image is the letter that goes after the line, right? So the image of 1 is B. The image of 2 is C. The image of 3 is B, right? Pre-image is going backwards. So the pre-image of C is 2. The pre-image of B is 1 and 3, right? B has 2 pre-images. Okay, these are names. These are names for all of this topic, and hopefully you guys knew this in the past. You saw this in the past, hopefully. If you were with me, I'm sure you saw it. Okay, so it doesn't matter, right? This element is in the output. This element has 2 lines coming to it. But this is an element of the output. So that doesn't really matter. That doesn't really matter. This, so far, would be a function. Now, there is a problem. Some books are going to say that this is not a function, and some books are going to say that this is a function. Why? Because the A is not connected to someone. That is a problem for some books. Simply because the A is not connected to some element in the input, some people say that that is not a function. Some books says that that is not a function. Now, the IB is not like that. The IB is not like that, right? This is a function for the IB. Simply because this is a function using this domain, this range. Using this range. If we use this range, the range is only B and C, then that is a function. All right? Also with this, what happens if I do this? If I do that, is that a function? Yes or no? In the chat, please. Nobody, Ala? Anybody? Don't be scared about making mistakes, guys. Just write down what you feel like. Okay, we have 2 people who are brave enough to say something.
Yes.
Mafe, thank you. You too. Thank you, Garzon. All right. Lily, appreciate it. All right, so to all of the people who answered, thank you for answering. It doesn't really matter if you're right or wrong, because I'm going to say the answer at the end of the day, all right? So the people who said that this is a function, again, it depends on the book. For some books, this is not a function because there's an element in the domain that is not related to some. This one doesn't have an arrow. But for some books, this is a function. Why? Because this could be the domain. If we say that this is the domain, then that is a function. That is a function. Right? The IB is going to recognize this as a function. All right? The IB will recognize that as a function. This, for the IB, this is a function, guys. All right? Okay, cool. Now, this is F, right? This is F. This is the function F. Let me just do it like this. All right. This is F. Now, this is the function F. How do I know this is F? Because I just name it F with a little f over there. Right? Let's think about f to the negative 1. In other words, the inverse of f. Guys, knowing that the inverse means going backwards, f to the negative 1. Is f to the negative 1 a function or is not a function in this example? Okay. Going backwards means if the line was from 1 to B, now the line, all right, with purple, I did F, all right? With red, I'm going to do F to the negative 1. So this is part of the function of the inverse, right? This is part of the inverse, right? And this here is part of the inverse. As you guys see, all I did was going backwards from the same line. I just switched the arrow, the direction of the arrow. In the beginning, the line F was from 1 to B. The inverse is now from B to 1. Is going backwards. Same with every other element. From 2, I went to C. The inverse makes it so that from C, I go to 2. All right? Guys, answer please in the chat. F to the negative 1. So the inverse of F. Is that a function or is not a function? You guys go, please. All right, Ma Gutierrez has an answer. She doesn't know. Anybody else? Lily has an answer. Beautiful. Somebody else? Again, don't be scared about making mistakes, guys. Maybe one of you are saying, I think yes, but I don't know. I'm not sure. Don't be scared about making mistakes. This isn't a quiz. This isn't. I'm not gonna give you a grade for this. Just if you feel like something, write it down. Okay, Paul has an answer as well. Thank you, Paul. Somebody else? Nope. Okay, my turn then. My turn. All right. In the answer, let's take in the example. Let's take a look at the direction of the lines. We are talking about the inverse, right? And look, just like we did it with the main exercise, with this one over here, the x became the y and the y became the a. In other words, the dependent variable, the independent variable became the dependent. And the independent variable, backwards, the independent became the dependent and the dependent became the independent. We switch the variables. That is going to happen exactly here with the sets. One set is the one from when you come from. That is called the input. And if I change the arrows, that means the input change. So now this is the output and this is the input. Sets changes as well, simply because the direction of the arrows going backwards makes it that way. So the input is now A, B, and C. That is the input. And the output is now 1, 2, and 3. So to look for if this is a function or not, we're going to see how many are related to. So B is being related to 2 outputs. In other words, B has 2 images. And that cannot happen in a function, right? An element in the input cannot have 2 images. And B, which is in the input, has 2 images. So the function f to the negative 1, the inverse of f, is not a function. You see? Sometimes we have functions that have inverses. And sometimes we have functions that don't have inverses. All you have to look for is the main rule. In the input, no element can have 2 or more images. All right? Let's see the chat. Congratulations to Lily and to Paul. You guys got it correctly, guys. Congratulations. Also, Juan David Garzón, you were kind of correctly because you didn't know at the end, right? You said no. And Majo, entonces no sería. Okay, Majo, pretty good. You said, ¿también cambian los inputs y los outputs? Yes, they also change. So you are correct, Majo. Keep it up. Pretty good. All right, with this little bit of a review, because again, you guys saw this from 9th grade, right? So with this little bit of a review, we can now go back to the questions from the book. All right. So the questions of the book. The questions were, what was the question? Here, right? This is the question. Let me just copy it here so we can do it. All right. So we are finding if why each function has an inverse. We need to explain why each function has an inverse, right? So let's go back to the exploration so that we can see the functions. All right, these are the functions. B, C, and D. All right, so let's try to explain. That's what we want to do, right? We want to explain why each function has an inverse. Let's try to explain why B has an inverse. Why? All right, let's read it. The number of pounds in weight, P, related to weight in kilograms, K. Okay. So if we were to do a drawing of this, we have something like this. Have one circle and then another circle. In this first circle, we have pounds, and kilograms. So this is P for pounds, this is K for kilograms, right? The amount of pounds, so I don't know, any amount of pounds. So 1 pound, 2 pounds, 3 pounds, 4 pounds, and so on, right? And in kilograms, we have, I don't know, 1 kilogram, 2 kilograms, 3 kilograms, 4 kilograms, and so on, right? Now, the lines, how would they be done? Like this. We notice that 1 kilogram is equivalent to 2.2. So I have to raise this. Because now, from 1, I'm going to make a line to 2.2, right? 1 pound. No. Let me do it backwards. I'm doing it wrong. 1, 2, 3, 4, there, right? So 2.2 pounds are 1 kilogram, right? P related to kilograms, yes. Did you see? Now, the second one. 4.4 are 2 kilograms, right? If we continue like this, 6.6, 8.8, and so on, if we continue like this, right? These are functions. This is a function because every element, of course, this has infinite amount of elements in here. We can have any amount of pounds, right? But every single element in the pounds has only one image on the kilograms. So this is a function. F is a function. Does this have an inverse? Yes or no? Well, yes, this has an inverse because the inverse means going backwards, right? Going backwards means instead of from 2.2 going to 1, you're going to go from 1 to 2.2. The idea is go back in the same line from this to this, from this to this, and from this to this, right? So pounds and kilograms are related so that each pound has an amount of kilograms. The inverse would make it so that each kilogram has an amount in pounds. There is no possibility for a kilogram to have 2 pounds. There is no possibility. So the first example has an inverse. That is the reason why, right? All right, the second and the third, I'm not gonna do it because I want you to practice yourself. All right, let's jump into the next question. No. Here, question 1, question 2. State which of the following functions has an inverse, given a reason in which case. All right, this is gonna be pretty simple because we did exercises of this, huh? All right, the function f goes from A to B. Now, -2 is related to 4, -1 is related to 1, 0 to 0, 1 to 1, and 2 to 4, right? These the function, the f is a function. But this f has an inverse. In the chat, let me see if you guys get it or not. Right? Tell me in the chat. This f has an inverse or not? Nobody? Okay. Paul says that no sabe. All right, let me show you how. This is the function, right? We know that f is a function because from every element in the input, only one line is coming. Right? Only one line is coming. So f is a function. But the inverse means going backwards. So like this. That is the inverse, going backwards. And just with that example that I just did, the 4 has 2 images. 2 lines are coming out of the 4. So this is not a function. The inverse cannot exist because it's not a function. The inverse means going backwards. But remember, in this case, if we find an element in the first set in the input, this will be the input now. Input. This will be the input. An element in the input has 2 images. Is related to 2 elements. Has 2 images. That from there, we do not have, this is not a function. We don't have an inverse. All right. Now, maybe I wasn't clear in that point, but anytime, an inverse, when we try to find an inverse, and that inverse is not a function, this is awful. Sorry, guys. Whenever the inverse is not a function, then we say that the function doesn't have an inverse. Have an inverse. Sorry, guys. That is awful. Sorry. Again, if the inverse is not a function, then we say doesn't have an inverse. All right. So that is for the first point. Real quick, the second one. No, real quick, no, because we gotta go to eat. Gotta go eat, guys. And we didn't have enough time to practice. All right, let's do something, guys. If you want to practice this later in your home, that's okay. But for today, we didn't do any classwork. All right. For today, we didn't do any classwork. So I'm expecting 0 exercises for today. All right, guys. I am not giving you classwork today. I'm not giving you a homework. If you want to practice, that's okay. Maybe you guys like mathematics. Maybe you guys want to practice more because, I don't know, maybe you're interested for your internal assessment. Whatever. Go ahead and do it. But you don't have to, right? This is not a homework. What we're going to do the next class is jump right into these exercises. That is what we're going to do the next class because there are a lot. Look, from 5G, there are a lot. And just the fact that you guys didn't answer in the chat makes me think that you guys don't remember anything of these. So we got to practice. All right? So that is what we're going to do the next class. For the rest of the day, guys, I hope you guys have a good one and go grab something to eat. See you in the next class, which is after the break, right? After the vacations, right? Yeah, we don't have any more classes. So hopefully, I hope you guys have a good vacation and see you. Bye bye, guys.
Chao, profe.
Chao, profe.
Ciao.
Chao.
Gracias.
Chao, profe.
Ciao. Ciao.
Chao, profe.
Ciao.